So if we middle click on this, we'll have our information about our SOP. So you can see here this torus is comprised of 800 points and one primitive. It's 861 vertices in one mesh. It also gives you the bounding box information, how many point attributes and vertex attributes, which we'll get into I think later. So I just dropped down a noise SOP. If we hook that up, this is a fun one. Noise torus. I don't know if you guys can tell, but the shading here. Let me bring the amplitude back down a little bit. Reasonable. The shading isn't really being updated. That's because the noise operator only affects the point positions, but it's not actually updating the point normals. And the normals are used for calculating lighting. So there's another operator called facet, which allows you to compute normals. So this is really handy if you're doing procedurally generated geometry and you want the shading to look correct. So there's just a compute normals button down here. And it's a subtle difference, but you can see if I turn it on, if I have it off, the specular highlights don't really move with the surface. If I turn it on, it moves in a more natural way.
When you check the compute normals function, just because of the processing?
There is overhead. Yeah, that's a good point actually. So SOPs are the rendering is all hardware accelerated, but all the calculations of SOPs do happen on the CPU, and it can get really heavy in terms of performance. So general rule of thumb is if you're doing anything with models or more complex geometry, it's usually not a good idea to have a dynamic procedural network. It's usually a good idea to have something that's relatively static, because that way when your program is running, it's only going to calculate everything once. That's how touch works. It only runs an operator when its inputs have changed in order to save CPU time. So right now it's calculating the normals and the noise every single frame because the noise is changing everything. All right, so yeah, you can see here the cook time. This is how many milliseconds it requires to run the facet. So if I were to go back to my torus and change the number of rows to 200 instead of 20, the cook time has gone up to 1.3 instead of like whatever it was, 0.3.
Yeah, you might want to talk about the lines showing the nodes are animated between the previous two, so that means that there's cooking happening, and the lines of joining the previous two are not animated. So zoom out a bit. Yeah, so the line joining the first two nodes are not animated. This one is. So this indicates that there's no cooking. That like the torus isn't cooking now, but the noise is and the facet is. So if you middle click on the torus, you can see the cook count. It has cooked 3 times only, right? See
yep.
the total
it's only
cook?
because it's never changed, and it's only cooked 3 times because I just changed the rows from 20 to 40 and back to 20. That's the 3 cooks.
Yes, that's right. So the other, if you middle click on the other nodes, you'll see that they're all they're cooking all the time because they're doing they're animated. The parameters might be animated, but it's being cooked every time. So that's Touch Designer cooks as little as possible. You know.
So some other really handy operators are the grid. This one is used a lot. Grid is just a plane. And we've also got a box. Oops. Pretty self-explanatory. You can change the size and the texture coordinates and so on and so forth. There's a number of different operators in here to do procedural modeling, but they're fairly complex to go into, I think, for this. But we do also have like a transform operator, which allows you to, I can scale. You can scale in a single dimension. You can translate. And similar to chops, we also have a merge. which allows you to combine different SOPs together into a single operator. Oh, another nice one is twist. So those are the three principal operator families. If you look at if we go back to the operator panel, you'll see we still have comps and DATs, which we're going to talk about in a second. But the first thing I want to do is talk about interoperation between all these things, and this is where touch really starts to get powerful. Is when you start to understand not only what you can do with individual operators working within the domain that they relate to, but you can start to take information from one domain and convert it into another domain. So for instance, if we go back up and look at our SOP network, let's go over here to our final. We can convert this into a CHOP. So if we go to the CHOP and choose this operator called, top 2. Now, obviously, we can't connect these together like this because they're different data types. This is 2-dimensional and this is 1-dimensional. So there's no direct way to connect them together. So now we're going to start getting into connections between operators that do not have this line connector, because that line connector only works with data that's from a single domain. So if we look at our top 2 operator, you'll see instead, there's a parameter field up here for top. So what I'm going to do is left click and drag this operator over into this field. And you'll know you're in the right place when you get that little plus icon underneath the arrow. And now you'll see that final is listed up here. So what we're seeing is a graph of the RGB values of a single row of pixels through the middle of this. So if we look at the top 2 parameters, you'll see we have red, green, and blue and alpha, so we can assign channel names to those, or we can remove the ones that we don't care about. So if I just want to look at the red channel, I can just make sure I have an R for red. If we go over to the crop tab, you'll see that we have crop type is set to row, which means that we're only going to look at a single row at a time. U and V start and end, and then we have V start. V start means where we're at in the image that we want to look at. So because it's 0.5, what the default of this is to pull a single row of pixels through the center of this. But if I move this around, I can actually sort of, if it's all the way over here, I'm pulling the last row of pixels, and if it's up here, I can pull the top row of pixels. Now, if you really want to get crazy, you can change your crop type to full image, which is going to completely crash the machine because it's creating 800 channels, and so you can see 690 more channels being generated on the fly. So generally not a good thing to do unless you I guess I could speed it up.
Yes.
I'm going to pause it for a second. So I'm going to go in here and add a top right now to change the resolution. So there's a resolution operator that allows me to change the resolution. All I have to do is go over to the Common tab and change resolution to custom resolution, and now it's 256 by 256 as default. So the aspect ratio is the same, but the size is now much smaller, 256 by 256, and now my top 2 is able to actually handle all that data. Yep.
Did you choose more than one row at a time?
That's what I just did. That's the full image. You can also do a single pixel. So this is just giving me the value of red for a single pixel within the image.
And then you start new ones as the coordinate.
Yeah, U and V
Oh,
are
U and V.
U and V are like texture coordinates basically, and they pretty much always go from 0 to 1. So the cool thing about this is that now I can use all of the power of chops to manipulate image data, or vice versa. So I can do stuff like we showed it before, like we have a noise operator. If I take the math chop, just like Greg had showed, where we combine things together, I can take the noise and the red channel and do combined chops set to add, I guess. So now I'm adding the RGB values of the movie to the noise. The reason why it's not doing the whole thing is because there's more samples in this noise channel than there are in the image sample, because that's only 256 samples if you middle click, and then if you look down here, we've got 600 samples. So one way to get around that is just to change the number of samples that I'm generating with noise, and you can do that by going over to the channel tab, and you'll see down here we have start, end, and sample rate. So by default it's 10 seconds at 60 hertz. So one way to be more precise about it, since I know that I have 256 samples here, is just to change my units to samples. And you can see here now it says 599. So if I type in 255, now we have 256 samples in both operators. And similarly, in terms of taking an image and turning it into a chop, doing processing on it with your chops, you can go back into a top. So if you look in the top operators, we have a companion one called chop 2. And it's very similar. So you'll see in the chop 2 there's a chop parameter. I can drag this chop into this field, and now I am creating a single row of pixels. So I mean, you can do stuff like, since we had some audio input over here, I can do the same thing with this. So I can visualize the audio immediately using a top. I can use chop 2, drag this into that, and now we have some pixel data that's being generated by this. I mean, if it's only 1 pixel tall, but we can stretch that out, and we can use a level top to make it brighter or whatever. So there's tons of ways you can go back and forth between chops and tops. And similarly, you can take a chop information, turn it into a top, and then apply levels or blurs or compositing or whatever, and then go back into chops again. So you can use the tools available to you in both domains to do interesting problem solving.
Let's change the resolution of it so you can see it as a bigger image.
We gotta do that with resolution, right? Yeah. So I just added a resolution operator. If you go over to the Common tab, you'll see there's an aspect ratio button. It's set to input by default, but I can say custom resolution, and that allows me to expand it out. So right now the custom aspect ratio is 1 to 1.
Yeah. And another way of doing that is setting the resolution to be 256 squared.
Right. Right.
And making the aspect ratio the same as the.
So this is a big image. It's a 16,000 pixels wide. So I could zoom into this pretty far, and it's pretty high res. So that's a pretty common thing, actually, for us to move between tops and chops. And there is a similar way to go from chops to SOPs, oddly enough. So I can take this information here, and we can turn this into 3D geometry. So if we look at our SOPs, there is a chop to operator. And we're almost ready to do this, but because we're going from a one-dimensional domain into a three-dimensional domain, we have to create a third axis. So in order to do that, we can add, let's say, another chop. Well, actually, you know what? Sorry, backtrack. Let's just go back to the beginning of our chain and take this filter and add it to here. So now we have 3 channels. So I just added filter to this merge again, so it's a duplicate, just in order to get 3 channels. So now I have chan 1, chan 2, chan 3. These could be X, Y, and Z, and in fact that's exactly what we can do with the chop 2. So again, I can just drag the trail operator into the chop parameter field, and then here it says channel scope. So channel scope by default is expecting me to send it channels that are called TX, TY, and TZ. So in order to achieve that, what we can do is just add a rename chop, and we can just type in this to field TX space TY space TZ. We don't need to change the from scope. If we wanted to be explicit and type in chan 1, chan 2, chan 3, we could. Or if we wanted to use different channels and different orders, we could type those in. But by default, it just does them in order. So now I have to drag this one into the parameter field. And it's not working.
Is the reason you're doing that because it's a different data type?
Yeah, it's a different data type, exactly. That's weird. Sorry, there's another way to do this. Yeah, sorry, I think limit was the one I wanted. Same thing, there's a chop operator, or a chop parameter field. If I drag this over, now, yeah?
Just go back for a second on the rename.
Yeah, so all I did was lay down a rename operator, and in the to field, I just typed in TX, TY, and TZ.
Which could be anything, or
It could be anything, but for this, because we're going into 3D, it's good to make sure that your channels are consistent with what you're doing. So TX, TY, and TZ stands for transform X, Y, and Z.
like some diagonal and name like that.
You can use anything you want. Yeah. So the limit SOP has a ton of different parameters. So you can see here we've got X, Y, Z channel, radius, alpha, we've got color information. So if we wanted to, could create channels for all these things, but the minimum is just TX, TY, and TZ. So I'm going to type in TX, TY, and TZ. And so now we have created some geometry out of our channel. Just to make it more obvious what's happening, I'm going to create another noise operator. Sorry, noise. So we're going to go over to the channel tab, and over here we have 3 different channel names, chan 1. So we're going to type in TX, TY, and TZ there. Now we have 3 noise channels, and we're going to visualize this. There we go. So now we have taken our 3 noise channels and created some 3D geometry to go with it. And again, it's all procedural, so if I change the periodicity or the seed, you can change everything in real time. So I can go over here to output on the limit, and by default the output's a polygonal line, but I can have it output tubes. You can change the radius, etc., etc. So you can do all kinds of crazy stuff with this. I mean, you could take audio information and extract the X and Y channels and run that into here, and now you have an instant 3D visualization of audio. Every single field inside of Touch Designer is actually a place that you can write code. You can actually write like really complicated like math expressions, and you can use any variable within the system. I'm just going to drop a noise chop down real quick. He had a good question. So by default, when you drop a noise down, you get this nice wave, but it's not animated. And as soon as we turn it into a time slice, it's animated, but now it's just one value. So there's a couple different ways to create animated noise that exists in this form. If you look at the Transform tab, you'll see we have this translation, rotation, and scaling. So if we translate our noise using the ladder slider, we can sort of move through the domain. The reason why this exists is because the noise function is actually a 3-dimensional noise function underneath the hood, so to speak. So you're passing in some X, Y, and Z parameters in order to generate these this string of numbers. So the way you can animate this is, rather than having a single number in here, you can type in like $F, which is a variable that stands for frame. So $F is this number that you see on your timeline. So when it gets to the timeline, gets to the end, it's going to jump back to the beginning. But you can put math in here. I can multiply it by 10. So I can type in $F in every single one of these fields. I can rotate. I can change the frequency.
Set of index values for a table, so when you use the limit.
Yeah, it's not a table though. There's no lookups. It's all being calculated on the fly. It generates a table. That's what a chop is. It's a sequence of numbers, of individual numbers, but it's not pulling those numbers from somewhere. It's just calculating everything on the fly. When you include the variable in it, that means that it's going to recalculate the wavetable every frame. Yeah, so their webpage, the derivative website, has a full list of every operator, what every parameter does. It's actually very well documented.
Is there a way to access what's online through the UI?
That's what he was just saying. I guess there is. You just hit the question mark button, and it brings up the website.
Awesome.
So it gives you all the parameter, like here's the noise types, what all the parameters mean, everything. Inputs, all the local variables that are available.